Jai Hind everybody. Today we would be discussing how a blockchain technology actually works in the practical life. So first we should come to know that what all in this digital world, the basic two questions we have to answer. First is, are we whom we are saying we are? That is, I am being an authorized user or not? And the second is, do I have the rights to do what I am trying to do it? Means first I have to have an authentication if I am that particular user which I am telling it. For example, if I am telling you that I am Rashmi Sharma, then you have to authentify that I am Rashmi Sharma or not. Second is, if I am trying to delete some data or if I am trying to access some particular data, then do I have the permissions to do that? These are the two basic questions which we have in this particular digital world, as well as we have this in our blockchain technology. So for the first question, the answer comes out by the authentication process, and for second, it comes by the permissions or the proof of permissions which we have or the authorities which is being given to us. So now we will discuss what do we mean by authorization and what do we mean by authentication. Authentication is addressed with cryptography blockchain. As we have already discussed in previous videos, the authentication can be done in two forms. One is by using the cryptographic functions which use asymmetric key, which uses public key or the symmetric key, and the second which uses asymmetric keys. I think everybody remembers the asymmetric keys. In this particular thing, we involve two keys. One is the public key and another is the private key. When we are generating the public key, simultaneously we are generating a private key also by using a complex algorithmic process. So this particular process is so complex. We have taken in the last video, if you have seen that, we have taken the example, a very simple example, but practically we don't use that particular thing in real life. Like if I'm generating the combination of public key and the private key, the public key plus the private key plus the public key should have a sum of 10. Okay, so we can have n number of combinations. We can have infinite number of combination. If I take only till 2 digit, if I'm taking this as 4.20, then obviously the public key can, because I need a sum of 10, so the public key can be 5.80. So that was a 2-digit number, but we can have 4-digit, we can have 6, after decimal we can have 6-digit number. In doing this, we are simultaneously generating this public key and a private key using a very complex algorithm, and that particular process is very complicated. It's not that anyone can generate that and use that in the normal process. So while we are generating this public and private key, we store, when we are having, in the last lecture we have discussed that we have generated a coin ID. I think you all remember we have generated a coin, and that coin was having a coin ID. That was the unique number, that's the digital currency. So for keeping this particular digital currency, or for encrypting that particular digital currency, I require a public key and a private key. So we refer to a public key and a private key, which is generated simultaneously using a complex algorithm process, and this is being kept into the wallet. Everybody has a wallet in their pocket. So this wallet, you have a currency, you have your cards, you have your identification proof. Some of the data which you think is important is in your wallet. So this digital wallet, what do we keep? We keep this particular public key and the private key, so that we think that what all things are important, along with the coin ID. So this particular coin ID is being stored into it. So the wallet is a software program which has program not only stores the private key and the public key, but it also stores the currency. That is what all things we are receiving and what all things which we are giving. So when we have the physical wallet, we only keep the currencies which we have. We don't keep another person's currency. But in digital wallet, we keep a record of what all currency we have given to a particular user, or for transacting that particular blockchain, what we have taken in exchange and to whom we have given it. So what all things we keep? First is the public key. The key, the values contained is public key, then the private key, the money which is coming in and going out. I'm giving to whom I'm giving, I keep that particular transaction also. And then I keep the balance, what is left with me. Along with, if I'm creator of some particular coin IDs, then I keep those particular coin IDs also if I have generated those particular digital currencies. So these are basically 5 to 6 things which we keep in the blockchain wallets. First is public key, second is the private key, which are being simultaneously generated by a complex algorithm process. Then the money which is coming in, the cryptocurrency which is coming in, the cryptocurrency which is going out. So we keep that, and then the balance, what is going out and what is being in, then the balance. And if you have created some of that the coin IDs, if I am the creator of some coin IDs, then I keep that particular coin ID also. So these are some of the things which we keep in our wallet in the blockchain system. The only difference from the physical wallet is we keep what is we are going out also. So going out, and we are not the creator of that particular money. So two things additionally which we are keeping in this particular blockchain wallet is the going out currency and the creator of that particular IDs. So the private key must be maintained. Obviously, as the name suggests, private is confidential. So it has to be kept with the owner for whom it is being made, and the public key is distributed to each and every person which belongs to that particular network or the blockchain. So the private key, as the name suggests, to be kept with us, and the public key to be distributed. Example, our email addresses. Our email address is our public key which is distributed to each and every person, and our personal data, if we lock it, that has to be personal data or the password. We don't give it to anybody. That is the private key. So this is how we guarantee the authenticity. Whenever we are sending that particular data, then we are looking into 3 different forms, that is called as the digital signature. And in the digital signature, we have 3 different forms. We have to generate the public key and the private key. We have to sign that particular algorithm, use the signing algorithm, and use the verification algorithm. So for authenticity, we should ensure that the data is not being tampered by any other user in that particular network. So this particular authentication act as a digital signature which provides the validity and authenticity of who is the person who is sending that particular data. So the digital signature algorithm has 3 different steps. One is generation of the public key, private key, then signing of that particular algorithm, and verification of that particular algorithm. We would be discussing these 3 particular steps in detail so that we can verify who is the owner, or the one which is sending is the authenticate person which is sending the data or not. So for the generation of the public key and the private key, as we have discussed, that we encrypt the data. First of all, we generate. The steps is, first of all, we would, I have some space, I'm looking into it, okay. So in this, first thing is, what we are doing it, for generation of the public key, first is I am generating the public key, PUK is the public key and PK is the private key. Okay, so we are generating the public key and the private key, which helps us to encrypt the data, and the public key help us to decrypt that particular message which is being sent by me. So this public key cryptography blockchain ensures that it is secure and the transactions which we are doing it has a timestamp associated with. We will discuss this particular topic more in detail. See, if I have a message X, this is the message, okay, which I have to send. So for sending this particular message, I have to verify that I am sending this particular data. So I have to have a digital signature. So I do this particular signature by using my private key. So by using a private key, that is PK of X. This is my private key. So by using the private key, I have encrypted this data and converted to X dash. Okay, so this shows that I am the user, or authenticating that I am the user who is sending this particular data. By encrypting with my public key, the person who is having my public key can decrypt this particular data. So encryption is done by my private key. Now I have to send to some person. Say I have to send it to person A, and that name is Ravi. So for sending it, I have to encrypt this particular X dash which I have got from encrypting it by my private key. I will encrypt it by his public key so that it would tell who is the intended user for this particular, or intended receiver for that particular message which I am sending. So then you will encrypt. See, I am encrypting the X dash, not the X. Encrypting X dash and getting X2 as the result. Now I am sending X2. Okay, this X2 is broadcasted to each and every person. Okay, now only X2 can only be decrypted by the person who has the private key of that particular person. So private key is confidential. I am having my private key. Similarly, that person would be having a private key. So assume if this is person P1, this is person P1, and this is person P2. Only person P2 would be able to decrypt this particular message, that is X2. So what that person P2 will do, it will decrypt it and it would get something like X3. It can be any value. So it would this P2 will decrypted by his or her private key. Okay, now it get X3. Now this X3 is being again decrypted. Now here it is for intended user, that is for security. जिसके लिए बनाया, सिर्फ that person would know कि this is made for me. That is the signing authority, the integrity or verifying person. Now this X3 is again has to be decrypted to get this particular X value. So what we will do? We will do it, because here it was encrypted by my private key. So it would be decrypted by my public key and it would give the message X. Okay. So here we don't get the same value, but the resultant output is the same, because we have a combination of the private key and the public key, which generates the same results. So this is the actual process which is being taking place in this particular verification, validation, and each and every step we will discuss how, where, what we are doing it. So first of all, we have generated, the first step was generation of the public key and the private key. These keys are used to encrypt and decrypt the messages. So public key is particular to ensure the security of the transaction, that to whom we are sending that particular data. Along with that, we are keeping the timestamp. Keep that particular ATM withdrawal example in their mind. Whenever we are withdrawing any money from the ATM, we have that particular paper slip that tells you at what time, from which ATM, which location, what amount was being deducted from which account. So those particular details have that timestamp and the location also. So here also we are taking this particular timestamp into consideration for each and every transaction. So obviously this is a unique time. Why for ATM, why we are taking two more things, that is the location of the ATM also, because at the same time multiple people can withdraw the money, but from different locations or from different ATMs. But in the blockchain, in one particular blockchain, only one person can do that particular transaction. So here we are not taking that geo services into picture. So here we are only taking the timestamp which is unique, and we are making that particular transaction unique. Now, signing. The digital signature provides the safeguard the integrity of the data. Integrity is the person who is sending it. So this is done by combining the private key with the data. Then they wish to certify the mathematical algorithm. So here, this particular algorithm, this particular encryption tells that we are integrating that particular data. The signing authority is person P1. The intended for which whom that particular user, the sender is P1, the receiver is P2. So for sender being P1, we have to encrypt it by P1's private key, and the receiver is P2, we have to encrypt it by the public key of the P2. While at the receiving end, the receiver would do the decryption. For decryption, we will use the public key of the sender and the private key of the receiver. So for verification algorithm, we process the viewer and see the authenticity and the integrity of the receiver. So this is the whole process. In short, the message is being encrypted by first the private key of the sender, which tells that act as a digital signature, who is the person who is sending that particular data. Second is we are encrypting that particular message with the public key of the receiver, for whom that particular message is intended. On the receiving side, first we will do a decryption by using the private key of the receiver. Then second step is public key of the sender, and we get that particular message. This is how we are doing this particular authentication. So in the verification process, it seems that we are doing a much work, and it is visible, and this particular data would only be visible to the end user or who is doing it. So this digital signature acts as immutable things in the blockchain. We have discussed immutable, the things which we cannot change, that cannot be tempered, that cannot be updated. So encryption and the digital signatures are the two technologies which guarantees authentication, obviously, of the sender, integrity of the receiver who is receiving is non-repudiation, not sending that particular data again and again, or nobody else can temper that particular data for the requirement of transactions. So by the digital signature, we get the answer, are we who we say we are? Because I'm giving my authority or giving my identity by signing it by my private key, and the person can decrypt it by using my public key. Okay, that was the first question which we have answered in the blockchain. The second question is, do we have the right to do what we have? So obviously in that particular thing, the authorization creation is addressed by our distributed consensus, and here we use a P2P, that is peer-to-peer network. This is called as peer-to-peer network. That is, peer is each and every node. So we have a decentralized system for today, and we don't have a central authority which defines the rules, which has the full control, and the data is being used by each and every node. They have that particular data on their devices. That devices can be their computers, that devices can be their mobiles, which are connected in that particular network. So we ensure that we have that particular right rule in the blockchain protocol, and for this we require a distributed consensus. The consensus means we have an agreement with each other. Obviously, we rely on each other and we have an agreement. Distributed, like we have seen the distributed ledger, each and every node has an individual copy of their consensus agreement. So we don't have any hierarchy like we have the hierarchy in the normal bank transaction. The bank server or the RBI, then the bank server, then the head branch, and then the branch offices which are there in different cities. So in that particular case, we have a distributed consensus, and in distributed consensus, the main thing is there is no hierarchy within the network. So first was, if we are the user whom we are telling it. Second is, do we have the right to do that? So all the nodes in the peers have the identical copy, as we have discussed that in the distributed ledger. That ledger has a local copy of that ledger is there on each and every peer, each and every node which is there in the blockchain. So in the blockchain network is called peer-to-peer network, since the tasks are being maintained on a continuous shared basis. Whenever a single thing is being updated, it is being reflected or it is being broadcasted to each and every node which is there in that particular network. So it spreads and controls the responsibility among a lot of different people or lot of different nodes. So there is no single point of failure, and that reduces the risk of corruption also, because each and every person is responsible. The person who will do some particular tampering or some corruption, then that person can be easily find out, easily pointed out that that person has done it. So there is only there is no single point of failure. If one node gets failed in this particular network, if I have one single node which get failed, so that doesn't mean that I cannot have a transaction with all different other nodes. I can have a transaction, they can have that particular local copy or the distributed ledger copy, and we can continue with those particular transactions. So if that particular person is not having some connection problem or having some particular issues with the hardware or the software, if this particular failed system fails out, we can use another nodes for that particular thing. And it reduces the risk also. If a single person is doing something wrong and that is being broadcasted to each and every person, they would let him know that you are doing something wrong, and they won't validate that particular transaction also. So this is how they stop the failure issue which was there in centralized system, and the tempering issue which is there in some parts of the some part of the decentralized system. So these are the two main issues on which the blockchain technology works, and that helps us in for telling us that these particular blockchain technology is authenticative, integrative, non-repetitive, and we can rely on this particular technology. So next comes, what are the different components of the blockchain? There are 7 different components which are a part of this particular blockchain. One is the node. Node are basically all the physical devices which are being connected in that particular network. They can be your laptops, they can be your desktops, they can be your mobile phones, or that can be your iPads or your small palm tops, PDAs, and so on and so forth. Then we should have a distributed ledger, a wallet, a nonce. A nonce is a random number, and that random number is being generated depending on that. We can have a random number between 0 and 1, which up to 6 decimal places, or we can have a random number from 0 to 100 up to 3 decimal places. So we can have any nonce is a random number which can be generated. It depends on that particular network, what range they decide, what decimal places they decide. Then hash, we would be discussing this hash more in detail. And mining, who can act as the unique person for taking off that particular transaction, and what are the different consensus protocol as a component. So one by one we would be taking all these particular components. The first component is the node. So node is an electronic device, a computer or a mobile that is being connected to the internet. Main thing is internet. So any computer or the hardware device that is connected to the blockchain network ID is a network is a node. All the nodes in the network have a copy of the blockchain ledger. Obviously, we have discussed that all those nodes which are there here, they have a single copy. They have the local copy of that particular ledger. So this is the copy. This is the local copy which they have. So we are telling this particular local copy should be there on each and every node. So blockchain exists on nodes whose primary purpose is basically to preserve the integrity. That is, the data should be same on each and every nodes. We cannot have different data on different nodes. Then that would defeat the concept of this blockchain. The node supports the network by maintaining a copy of that particular blockchain. So these particular nodes can be of two types. One can be the full node. Second type is the your partial, lightweight, or your light nodes. So we'll see the differences between these two particular type of nodes. First is the full node. Full node maintains a full copy of the transaction history of the block. That it has each and every transactions starting from that particular coin which has been generated. For example, if I take the bank example again, the day when you have opened that particular account, assume that I have opened the account on 1st September 2003. From that day till today, that is 21st March 2022, I have all the transactions in that particular node. All the each and every transactions are there. If I have done 11,438 transactions, this particular full copy would contain all those particular transactions. So computers run full nodes to have sync the blockchain. They have sync who has taken, from where they have taken. So all the in short, I should say the statement when that particular blockchain was created till the present date is there in this particular full node. That is history of each and every transaction which has taken place in that particular blockchain would be there in each and every node, in the local copy of each and every node. So they also help the network by processing and accepting transactions blocks, validating those transactions and blocks, and broadcasting them to the network. So the main thing is you have to process and accept the transaction. Obviously accepting is by using the consensus algorithm, then validating these particular transaction blocks, and if that particular block is validated, then we will have that particular transaction broadcasted in the network. Okay, so this particular process of broadcasting and doing all this particular transaction, processing, accepting, validating, and then broadcasting is called as mining in Bitcoin and forging in Ethereum. These are the two different words which are used by two different cryptocurrencies. So first is you have to process that particular transaction, accept that particular transaction in the blockchain, validate that particular transaction, and then it is being broadcasted. This process is called as the mining in Bitcoin and forging in Ethereum. So this was how we have the data in the full node. In the partial node, we maintain only a partial copy of the ledger, as who is the early user or those who do not have sufficient disk space for the full blockchain. So a recent user doesn't want to know what all things was being done in the previous node. So the recent users, these are early users, is recent users or those who do not have sufficient space. So they would keep the copy of only few transactions. So the light node download only the block header to validate the authenticity of the transactions. And this is called as the simplified payment verification. What we are using, only the block headers, not the whole block which is being used. So they rely on the block node, the full nodes, for their latest headers and for the account balance and any transaction which is there which affects their wallets. So these particular partial nodes or the light nodes depends on the full nodes for keeping all those particular details. So blockchain network needs to have more full nodes operating within the networks to make it truly trustless and the decentralized system. We have to have a trustfulness and the decentralized system. So we should have more and more full nodes and less of your light nodes. So when we have this particular blockchain which is open to all, anyone can come and join that particular network and anyone can participate in that particular blockchain, then that is called as the public permissionless blockchain. and this is the example of Bitcoin. Any of that particular Bitcoin and the Ethereum, anybody can come and join that particular thing. So based on the business need, only type of the block evolving should have a private permission blockchain. We would be discussing these particular types of blockchain in coming videos and the consortium, but the basic which came into picture was public permissionless blockchain, in which each and every node can come and the blockchain is open, they come and add to that particular blockchain and they become a part of this particular blockchain. In the next video we would be discussing about the different other components of the blockchain. We have discussed the node, then we will discuss the remaining 6. Thank you for this video.